this week just to give people an update on where we're at and what we've been up to and to talk about our next steps. So Reed did the one on Monday and I'm leading the one today. And then we're also going to send this video out to the rest of the board. We know it's short notice and a lot of people couldn't make it, but given our timeline, we have to keep things moving. So we will go over this today and then also share the video and share the video with the rest of the board. Did you have anything you wanted to say before I start, Reed?
Nope, that's great.
Okay, great. So basically our goals for today, we want to summarize the progress since we last checked in the spring. There's been a lot going on. We've had some really big development sprints, and then demo the current state of the application and talk about our next steps and timeline. So just as a reminder here on the right-hand side, I have just kind of the general flow of how the Convergence Accelerator works. So we had our 9-month phase 1. And now we're in phase 2. We just wrapped year 1 of phase 2 at the start of September. So we're going into our second year. And then the goal is that we're transitioning by the end of year 2 into phase 3, where we're sustainable without NSF support. And I'll also mention that we did do our 1-year review, our reverse site visit with NSF. And that was at less than a year. We did that in June and we were successful in that. And so we have our second year of funding. Okay, so just a quick reminder here about what we're all about. So this is actually a screenshot from the webpage that we've set up for the project. So our mission statement is to better predict and prepare for the risks we're facing by putting the best hydrologic science directly in the hands of decision makers. And we really want to have something that is on demand and provides more than just stream flow. So thinking about groundwater and soil moisture too, and looks out for longer time periods. So seasonal outlooks. Where'd my mouse go? Okay, so we're building a web-based platform. So we're going to talk a little bit about the software and hardware we're using, but we want this to be a mobile and web-based platform that generates seasonal forecasts on demand. And just a little bit of a reminder, we talked about this more at our last meetings, but basically how we're doing this is we're using physics-based models that model all the dynamics of how water and energy flow through watersheds as kind of our the base of this system. And then off of that, we build fast running machine learning emulators, and we put that into our national framework so that we can generate things really quickly on demand. And our main differences that set us apart from other things is that we're focusing on longer time scales. So that's where the physically based modeling really comes into play, especially as we're looking at seasonal groundwater and soil moisture and antecedent moisture conditions can be really important. And this also sets us apart from things like 2-week weather forecasts. Because we're based on the physically based integrated hydrologic model, we can look at things like soil moisture and groundwater. This will also give us the ability to start simulating scenarios that fall outside of the extremes we've seen in the past, because we can create training data with our physics-based models that fall outside of that, which is something we can't do if we're doing a purely observation-based approach. And then we've done a lot with our software architecture to try to make something that is scalable and portable. So that's kind of just the overview of what we're about in general. Since we've last spoke to you, we've done a lot of development on both our data side of the platform, the software side, and the hydrology and the machine learning. So first we'll talk about training data and observations. So we have kind of 2 sets of things that we use as underlying data for this platform. The first is really part of HydroFrame, which is another NSF cyber infrastructure project. And this is all of the national parflow physics-based simulations that we're hosting. And in addition to all of the watershed parameters that we've put together in order to be able to run the parflow models. So things like topography and land cover, geology, those are all there. So that's kind of all of our baseline modeling training data. But in addition to that, and what I'm going to talk more about today is the work we've done to pull together point observations and remote sensing data products. And so that we're housing on Hydrodata, which is the repository we have at Princeton. And we basically have set up a system where we can automatically pull in observations from national observation sets. Obviously, these are all already freely available, but to make it easy for us to train and evaluate our models, we really need them in one place and we need them pre-processed because it takes too much time for us to do that on the fly. So what we're doing is we're pulling in data on a regular basis, and then we have an API built for our model development so that we can directly access it and compare across variables nationally at the timeframes that we need to for our model development. So currently we have on hydrodata all the USGS stream gauges, groundwater levels, soil moisture from SMAP, snow-till data, precipitation and temperature from NOAA. And then we have all of this data, as I mentioned. The key here is that we're pre-processing it. So we've already stored it in a consistent format where we can work with it across variables and on our domain. And we have everything in databases with metadata, so we can do quick queries to do any sort of comparison we want to do, and access it through a standard API. And then we have cron jobs that are running daily. So, and we'll see this in the demo, we're automatically pulling this in so that when we're generating forecasts, we do have the latest stream flow and groundwater levels, etc. So that's the brief summary of what we've been doing on the data side. In addition to that, then we've done a lot of work on the hydrology and machine learning side on our modeling components. So we really have three main things here. We have our hydrologic emulator model. So that's the model that mimics what we're doing with Parflow and the physics-based model. In order to initialize our emulator model, we also need current conditions. So this is actually another machine learning product because we need gridded current conditions of things like soil moisture and groundwater, which are not observed at the scales that we need them. So we use machine learning to fill this in, and we'll talk more about this. And then we have a weather scenario generator, which is what we use to drive the emulators. When we're looking out 3 months, we need some weather to give it. So all of this is done nationally, and we are storing it all at the Princeton Hydro Data Center, and we have API access from the hydrogen application. So basically what's happening is all of this is sitting here and ready when we want to do a watershed simulation. And yeah, hi, Tim. Okay, so the current conditions is what we're using so that we can generate our forecasts in real time to initialize our emulators, and then we run them forward with expected weather. So these are some maps of our current conditions. We need soil moisture and water table depth, and we can use those for building the pressure field for our emulator. So for soil moisture, we're using SMAP data, but then we have to spatially downscale that to 1 kilometer. And we do that using the watershed properties that are the inputs to the physics-based model. For the water table depth, we actually have a separate ML model that is trained to detect the relationship between water table depth, watershed properties, and historical weather. And again, downscaled to 1 kilometer using the properties of the model. So both of these models are running every time we want to generate forecasts. We have current conditions sitting on the back end generated nationally. Then for the seasonal weather scenarios, we have several options right now. We have some simple options where we just say, if you want to pick the top 4 hottest years or the top 4 driest years, things like that. But in addition, we're using the CPC forecast. So these look like this on the left here. They're seasonal outlooks of the % chance of precipitation falling in different categories, and the same thing for temperature. What you can see though is that these are not very spatially resolved. So what we do is we use this information to sample the historical weather based on the probability distribution provided here. So that way we can come up with gridded scenarios that are based on what the outlook is. So I'm not going to talk too much about what we've done on the back end with the software development, but we can, of course, get into that if there are questions. But basically what we're doing is a microservices approach, and we have all of our workflows containerized, and we use Kubernetes container orchestration. And the real advantage to this is that we're building the app right now. We're running it from the Princeton Hydro Data Center. where we have dedicated resources, but the idea is that the large data sets will stay at the Princeton Hydro Data Center, but we can easily pick up the app and run it. We've tested running it now at Cyverse, and are also making it so we could run it like on AWS or any cloud servers. So that allows us to be much more portable and scalable. So in our development, we've worked really closely with Cyverse, which is a large NSF cyber infrastructure project, and they have a lot of expertise with Kubernetes workflows and with scalable workflows. So we've been able to really fast track our development by grabbing a lot of our architecture from them with their Kubernetes approach and all of their API-based access. And then I'll also note that we're using Keycloak for user management, which allows for a lot of easy user login, and that we're not maintaining a lot of stuff on the back end for our user management. As I already mentioned, scalability and portability are really core to our development approach. So for what we're doing right now, we could have built something that is simpler, but the idea is that we want something that can scale and move and run in the cloud really easily. So that's why we've used this Kubernetes and microservices-based approach, and we've been really careful in developing our APIs so that we can take basically the application and move it anywhere. Okay, so that's a summary of basically all the big things that we've been doing with development, and we're going to talk more after the demo about what we're doing next in terms of development and the timeline. But I can pause here for questions, and then we can show you a demo of what the app currently looks like.
And Laura, Tim has joined us.
Hi, Tim. Thanks for joining us.
So I've got a question. Is
Yeah.
Hydro data publicly available? Could I use it, I guess, today if I wanted?
Reed, do you want to talk about that?
Yeah, maybe and stop sharing your screen so we can all see each other a little more easily.
Sure.
So Dave, the answer is not yet, but the answer is that yes, that will be publicly available. And a big part of the architecture is that Hydro data is going to be completely, you could think of it in two pieces. You could think of it as HydroFrame, Hydro data, and these are, open source data sets that anybody can use. And then Hydrogen grabs that data, grabs those data, and then uses it in the application. The application can run anywhere. And so technically the application isn't running on the PHDC, it's just running on a server that sits at Princeton. And it interfaces with the Princeton Hydro Data Center in using API calls. And then that's been already launched on Cyverse. So everything runs in the Cyverse cloud, which is just same architecture as a commercial cloud. It's just an academic cloud, and still makes API calls back to the Princeton Hydro Data Center. So the idea is that we're sort of developing like three things in once, kind of a unified data interface, that we can use internally as well as will be exposed externally. These archived model run and data sets that are used internally for training models, but then are also available externally through HydroFrame, and then the Hydrogen app, which is sort of the platform that we're we'll discuss how we're planning to provide access to.
Okay, so given that you said that it's mostly using publicly available data, is the value add that you're effectively taking this data, which comes from all different sources and all sort of different formats and weird sites perhaps, and putting it in some sort of a standard one place way to access it, I guess?
Yeah, so I think there's two different pieces here. I mean, I think the Hydro data thing is something that we didn't even plan to do. It just kind of outgrew from the project, and it's become something of its own thing. And essentially, we were building APIs to interface with all of these different disparate data sources, publicly available data sources. And it was a giant mess. Some, like the USGS, have great APIs. Some, Western water say snow, without naming any names, definitively snow available, it's really more scraping. It's not even API. You're just sort of tricking the web-based interface. And then, there's all these conditionals and all these things. Some are really fast access, some are incredibly slow, some are published at varying intervals, some are gridded data, some are point data, all of which we need for the platform, all of which we need either to train model, well, and then that doesn't even include our archived model simulations. So our archived model simulations were, really part of HydroFrame. They're not sort of the observation piece. And that's what we're training models on. But then we are building, it's not ready for rollout yet, but we're building a model evaluation and basically a calibration, a simulation-based inference platform that needs fast access to these data. And then the current conditions also needs fast access to these data. So the current conditions is another ML platform that we've built completely since we last met with the board that is purely data-driven. And gives you sort of how much water there is in the US from a purely data-driven standpoint, and needs a bunch of data that we didn't even really sort of consider, and has to pull in all these disparate data sources, and it needs to be really fast. And the only technical solution was to just pull everything down, which was not our original plan at all. Our original plan was to build these APIs to all these other data sets, but it was so slow and so haphazard that we ended up just building our own interface. And then we thought, well, why don't we make this another component of the model? So this is something that in the last, I don't know when we met last March, in the last 4 months or 5 months, that we've just built just because it sort of arose out of necessity. And it's really tricky because it's some things like remote sensing products, some things that are point data. And so, organizing the databases and orchestrating all of this has been something, of an undertaking. And that's in addition to what I'm going to show, which is the big value added, which is the machine learning emulator that runs on demand and provides a 3-month forecast.
Okay. Yeah, I mean, I guess I agree with you, and I've experienced the difficulties of trying to get data from disparate sources. So having it all in one place in a standard way, perhaps curated somewhat, would certainly be good. And I guess it's probably important to align what you're doing with sort of other standardization efforts. I mean, there has been, I think back to the WaterML work with Quasi and other Quasi things. I mean, certainly having it on your server for quick access and in a format that you can work with has value to it. But I guess, is it another standard, or is it going to use existing standards, or how's that going to all work?
Yeah, so unfortunately, it's probably a mix of both, right? So It is, all of the other, we did quite a bit of legwork on all of the other standards, and they're all standard interfaces to the data wherever it sits natively, which is a different approach than what we needed. And so what we have is a very standard, it's a Python library you just install. And right now it works internally in our system. The idea is to have it work externally as well, which will be pretty soon. And it's one consistent call, and then you just tell it the data type, or one query, and it gives you all the different data types. And that's across, all different agencies, all different, whether it's gridded or point data. And so it's been, kind of a lot of work, and it's been just one software engineer FTE working on this, just this piece, which wasn't, 4 or 5 months ago, this wasn't even the plan. We were still leaving the data in place and just querying it. And it turned out for some data sets to be too slow. So anyway, other questions? Should I dive into the demo? I'm not sure if I can.
Go ahead with the demo.
I need to.
Oh, go
my
ahead,
screen.
Tim.
Hey,
You have a
Tim.
question?
Yeah, I had a question. You may have already talked about this before, but with the forecasting, are you looking at more monthly short-term forecasts, say 3-6 months out, maybe a year or 2 out? Or are you looking at long-term, several-year forecasts? And if you are doing the long-term, how do you handle climate control? I mean, not climate change. Like in the Southern California area, I've seen studies where the wintertime rainfall is expected to get less in the future, but actually summertime rain is supposed to increase. So there is a monthly scale factor to it. And I wonder how you handle that for all the different local areas in the country.
Yeah, so that's a really good question. So we've been focusing on 3-month forecasts for now, just to have a consistent target within our team. But we would like to have longer term forecasts, and we do what we could see being useful, which is something we're not supporting right now, but has come up in a lot of different meetings we've had with people, would be the ability to run like 30-year alternate scenarios to explore just like what's the different range of weather that you could see. Definitely what we're getting at as we're starting to incorporate the CPC scenarios for weather is the ability to say like, yeah, okay, we might see hot and wet, and so you want to bias for what you're expecting to see in that coming season. And we have basically the scenario generator right now is just like we're building options onto it. So as we move forward, we can also have additional scenario generation options where we can have like more extreme rainfall scenarios that you could generate. So that's something that we have kind of a baseline capability now, but we really want to build on specifically for thinking about extreme events and weather that falls outside the weather that you've normally seen.
Yeah, and to augment that a little bit, so Tim, the first example is really driven by the Bureau of Reclamation. And they really wanted this 3 to 6 month seasonal forecast. But we're just generating daily, daily forcing variables to run the model, and the model's general. So, these climate scenarios have come up a lot, longer term scenarios have come up a lot. And then one of the early postdocs on the project is just had a paper accepted on kind of this idea of being able to train on extreme events, train the model on extreme events that haven't happened yet, and showing that that produces additional fidelity, which is something that we've talked about in this to the board before, but we now have a publication that's about to come out on that. So all of these things are very possible. And maybe I should jump into the demo and kind of walk through some of these things. Gary, I think I need to be able to share my screen. Perfect, thank you. Okay, so I'll dive into the just the splash screen. This is the our kind of placeholder for our URL, hydrogeneration.org, and Laura showed a screenshot from some of this. This is just a kind of a quick overview of what the project is, and then separate to that is the app. And so I'm already logged into the app. I just kind of, I could walk you through sort of the splash screen of the app and the Keycloak login process, but this is really the main dashboard. And so what you see is, here's a list of runs that I've done before, and kind of their current status. There's a create domain picker, and then you'll notice, as I'll kind of dive into, there's a bunch of help, bunch of other help and breadcrumbs and other kind of context sensitive hints and tips. So it's really sort of a more full-featured app. So for example, how to create a domain, et cetera. And we have a whole education outreach team that is developing these, and we'll continue to develop those out. All right, so I'm gonna just pick a domain name. That's 21 September 22, and then define the watershed area. So we jump into a watershed picker. This is CONUS 1, and notice that we are CONUS 2 ready. So the CONUS 2 domain is being spun up, but all the data sets and everything are ready for CONUS 2 once that model is online and fully trained. Now we can zoom in, and you can see that our HUC level is changing. So we can zoom in and pick a watershed here.
Can you only pick predefined watersheds, or can you pick an arbitrary watershed, say to a stream gauge?
So currently you can only pick predefined, but the plan is to be able to pick anything, and you can pick multiple watersheds or nest watersheds currently, but the capability is there to pick anything you want. So I am going to pick the watershed that I currently happen to be sitting in. So I'm going to pick Clear Creek above Golden. I'm going to hit create domain, and then you'll notice that this shows up in my dashboard. Now you'll notice we have a little status bar. It's collecting data. And so what it's doing is it's actually grabbing a bunch of information. So it's doing a query and it's pulling the current conditions in. It's pulling in the all of the data sets from HydroData, it's doing an API to itself, effectively doing an API to HydroData, pulling all this together and then prepping this within my user directory. And so this sits here, it's got information, it's got the Huck kind of name, and then, we can share and do different things. And we can jump into exploring results right off the bat, or we can jump into generating scenarios. And noticing that, we've got help all over the place, all sorts of different ways to provide the user feedback and information about what they're doing. So I'm going to show you the current conditions first. And so current conditions, water table depth, soil moisture, and then notice that we've got two different ways within the dashboard. We've got, observations for stream flow here. And then we have just a demo of a full observation kind of interface. And so, we could pick Clear Creek at Golden. And I believe these are being picked, I think these are being pulled every week, not every day, as Laura said earlier. So there's a cron job that runs weekly that pulls these in. That's an arbitrary thing. This is just what we're currently doing. And you can go through and, sort of explore the data, but note, we have the data pulled in and we're just showing stream flow, but we've also pulled in groundwater, snow, other data sets as well. Now, and then again, context sensitive help all over the place. So if we go back to the dashboard, we can generate scenarios. And so notice the scenarios, these are all the scenarios that we have so far, but this is something that we can build out. And so average, hot, wet, dry, and then CPC forecast. So we have archived 40 years of forcing at hourly time resolution, and then the app is actually pulling from daily averages of that 40 years of forecasting, 40 years of sort of retrospective reanalysis of the weather for the continental US. And so, for example, if you pick average, it will take the average in number. In is currently 4, but that ensemble number is whatever we want. This is just a demonstration for the app. So it'll pick the average 4 years. It'll pick the hottest, wettest, driest, or as Laura mentioned, it'll pick the CPC forecast. And so what this does now, when I hit build forecast, it's going to go through, query a distribution matching for your watershed, and then it's going to run the emulator for that distribution. Becky.
So curious on that CPC forecast, and I'm sorry if you stated this earlier, I had to send an email out, but so say the forecast is leaning towards 40% likelihood of above average conditions versus 60% likelihood of above average conditions. How does it differentiate between that?
Right. So I'll tell you that in a second. I want to point out one thing so you don't miss it. So it's generating the scenarios right now. So it's actually pulling the data, running the emulator, running 4 3-month forecasts for the CPC. And so the status bar is showing that as we go. I can answer Becky's question while we go. So super good question. And this was a little bit in Laura's slides, but we can revisit it for sure, because perhaps wasn't as super clear as it could have been in the slides. So the idea is that, exactly as you say, it might be, 40% chance of average, 60% chance of warmer or wetter or whatever. And so what happens is we actually do a distribution match. So we will match the distribution and pull from the archive and pick, of the sample distribution, we'll pick average years from the past 40, and then we'll also pick above average precip or above average temperature or whatever the CPC forecast to distribution match. So it's really a true matching of the distribution, and we rescale, renormalize the distribution on the fly. Laura, you can jump in on this too.
Yeah, I was just going to add too that I think that, you can't see it as much when we're only running 4. And the choice to just run forward is just to keep things simple for now. But actually, because we have the ML model already trained, running more scenarios, we can scale that up actually very quickly with no problem. So in terms of matching the distribution, it's a little hard to see it when we just have 4, but we could easily run like 30 or 40, and then you would have more. But we only have so many historical years to choose from. So if we're running 30 or 40, we're just picking like everything.
Exactly. Yeah. And again, and note, it's now scenario ready, so it's now finished. So it's run the entire thing. It's run 3 months of a physically based hydrology model via the emulator. And so these results are all now ready to go. And the archived forcing that we have comes from NOAA, but that's not the only one we could have. So we could pick different different retrospectives. We could pick longer time scale, longer time frames. There's a lot that we can do in terms of adding into the database, and that's all pretty straightforward to do. All right, so I'm going to jump into explore results. So again, remember this was our water table depth and soil moisture for our domain, and then we can jump over to our weather scenarios. So notice that now we have CPC forecast. So this is an idea. This is just a interactive dashboard explorer example of the different variables that we've pulled. So minimum temperature, maximum temperature, solar radiation, for example, and precipitation. And so these are pulled, as we mentioned, based on the CPC forecast. And then you can jump over to the watershed forecast. Now you can pick the existing forecast that's ready, which is the CPC forecast. And so what we have here is 4 ensemble members, 3 months of daily simulation. And something that we maybe didn't state super clearly is that everything starts today and runs forward 3 months. And so it's sampling from the CPC, say, hot or average. It's sampling from the archive September's for Clear Creek watershed. And then it's sampling from the archived Octobers and the archived Novembers. And if you did this in May, or if you did this in December, it would be adjusting for whatever time of the year you're running forward. So this is just an example. These are pretty straightforward, either time series of averaged over the entire domain, or snapshots spatially distributed of either soil moisture or water table depth. It's an entire 3D simulation over 3 months of simulation daily. So there's all sorts of things that we could do to kind of display the results in different ways. But we're just showing, for example, soil moisture at the top, and we can show the change. So we can show the different ensemble members and what the change at the end of 3 months versus the beginning. We can do the same thing for water table depth for these different scenarios. And then we can do the same thing for the domain averages. So what's the mean change in soil moisture? What's the mean change in water table depth for the different ensemble runs? And then we've got a map and widgets to show you where you are and such. And so this is really a very flexible system. So because this is all microservices architecture, this is a dashboard, and then this dashboard is running widgets on the back end. Those are microservices, and they're completely flexible. These are all built, and for example, we built these in Plotly. They can be built in a bunch of different interactive formats, and they're run as a separate service and then just ported through the dashboard. So developing different dashboards, developing different widgets within the dashboard is super easy, and it's really just the dashboard configuration is just changing a YAML file. It's just changing a database configuration file, and then each of the dashboards can be written kind of natively, and then there's a unified way that they interact with the user's data. So all of this is built with really good software engineering. Now, lastly, you can download results. So if you want to grab the forecast and you want to grab everything you see here, we just downloaded it now locally in a tar file. And you could do the same thing for current conditions. You can grab the current conditions or the observations, and then you can do the same thing for the scenarios. So the user can then grab this and pull these data down and do whatever they want with these. So that's the quick demo. And we can do this for larger domains. I have some really large domains here, like For example, we can do with more time, we can do a much larger chunk of, say, Clear Creek, or we can do the Taylor River, which is one of our other examples. And so if we go to point observations here, you can see with the map, this is the Taylor Park. And again, this is just for the average forecast, but you can see that we have the exact same thing for larger domains. So this is, and these take a little bit longer to run, but this is not, this is still while you wait. And then we have a full kind of help and explainer capability. So here are support tiles. These are just placeholders. The education glossary and explainers are not. So, for example, our education team has been working on different explainers that, kind of walk through different pieces of how the app works and what it does. So I'm going to end there with the splash screen and stop sharing my screen, open it up for questions, and then we have a feedback form. And Laura, maybe you want to jump in back with the presentation. We can kind of go into the next steps and the ask.
Mm-hmm.
And I've just
I
posted
mean,
the
I guess if
feedback.
people have questions first, and then I'll.
Yeah, sorry.
Okay, go ahead, Becky.
I think this all looks really interesting, and this might just be from a data geek perspective, which we probably all are, but I would be very interested in knowing, how much is a certain forecast being driven by the initial conditions versus the forecast. So like you showed like an average forecast, but the average is still building off of those initial conditions. So how different would that average forecast be if, i.e. there wasn't a drought or you are in severe drought, to kind of see how important are those forecasts versus the initial conditions, and not necessarily from the model perspective, but I mean, I guess it's from the model perspective, but just basically like, I don't know, something that would be very interesting to me.
Yeah, I mean, I can take a crack at that, Laura, and then you can jump in if you want. So through the Convergence Accelerator process, we developed to get our phase 2 money, to get our year 2 of phase 2 money, we developed the minimum viable product, or MVP as we call it, and you'll see that in the slides. So what we did was we streamlined down kind of the minimum pass through of all the capabilities. That's a usable app. It is a use case and a user story that we pulled from our partners. But one of the things that came up a lot from the Bureau of Rec is, what if we have, April 83 soil moisture and wetter than normal summer, or hotter than normal summer, or everybody in the Bureau has their favorite, their snowpack of record, or their certain, kind of favorite scenario that they always use to sort of test out inflows to reservoirs and things like this. And so that's definitely one of the scenarios, one of the case studies that we've talked about. And that would be pretty easy to do because we could pull initial conditions from anywhere in the archive, as opposed to pulling sort of the now conditions. The now conditions is harder because it involves a ML and involves this reconstruction of what we're at currently. So we figured that was a better path for the MVP. But there's a lot of flexibility as we take the app forward to do exactly what you're saying.
Yeah, I guess that would be like, scenario based, but you're not only changing the future possible scenario, but the current scenario that you're in, which, yeah, I think would provide a lot of helpful information. So thanks.
Sure, thanks.
All right. Dave, I see you're unmuted. Did you have a question, or it's okay if you don't? Dave Tarbutton, sorry, that was.
Did I have what did I do that indicated I might have had a question?
Oh, no, just you were unmuted, so I didn't know if you just unmuted to ask something.
I'm just, I have the habit of being unmuted, which
That's all right.
is not a good habit.
Okay, so I'll jump back to the slides then and talk about where we're at. So Reed has put a link to a Google form into the chat, and I'll talk a little bit more about that at the end, but we're happy to get feedback from all of you today, and then we're also going to be starting a more formal beta testing process. So we're also looking for people who would be willing to sit with our user experience team and go through some of this in more detail. So basically, Reed showed you where we're at on the app. Our next priorities are to do simulation-based inference, which is basically how we can calibrate our emulators to observations. Then to think about expanding our training data to cover more extreme events. So right now we're training on historical runs of the physics-based model, but we can target running specific simulations that are going to be valuable for training that fall outside the window of historical observations. And that'll allow our machine learning emulators to do a better job when we do have scenarios that fall out of the envelope of what we're expecting. And through that process, also to develop a system for identifying when we need to do more training or when we can say, okay, we can't support this scenario because we haven't trained our models on enough of this. We're also building a national model evaluation framework. So one of the big ideas of our approach is that we have the Princeton Hydro Data Center where we are hosting all of the observations that we talked about, but also where we're building and running these ML models and training these ML models nationally, so that when Reed showed you, he grabbed the watershed and it was running those scenarios. The reason why those can run so quickly in real time is because we've already trained that model nationally. So we expect that our national model will change. We've already had multiple versions of our national model, and we have multiple versions being developed in parallel. So on the back end, we want a national model evaluation framework where we can easily compare to observations and have benchmarks to see how our ML approach is evolving over time. And then we're also working on ML operations infrastructure, which is just a way of helping us standardize and version control all of our ML modeling, which will support ongoing research, but also if we're developing custom models in different domains, depending on who we're working as potential clients, that would allow us to do that in a really reproducible way. For the platform development, we're doing more performance testing and optimization for computing and data management. It runs well now, but we can always make it faster and work on our data management as we're doing bigger things that we're going to have to pass back and forth. We've started on our portability testing. We have a test going on Cyverse right now. And the way we're treating Cyverse is as if it's any other cloud platform. So we'll be able to then test on additional cloud platforms. Adding additional QA, QC unit tests to our development framework. This is really key to make sure that we actually have a stable application moving forward. Implementing federated data and metadata management systems. So we've been working a lot on our database systems over the summer so we can have standard access and good metadata when you're getting data back. And then also through Cyverse, we've been working on, we've talked about revenue acquisition and quota management systems. So once we have users, we need ways of having things that are free. And then if you're doing more, or depending on our different pay models, ways that people can actually pay us to do more operations or do more customized operations. So in terms of our timeline, we're really trying to support two things going forward. So as you remember from the first slide, we're in the second half of phase 2 right now, and we're really actively working on how we can be supported for phase 3. So we're working on launching a nonprofit company where we can develop and support the national platform, and we can have paying users that would be paying for customized options. So we do envision that we would always have a free version of this, but we could see that there would be users that would want a customized dashboard for their needs, or things that are running all the time, that they're getting standardized outputs, things like that, and that we could generate revenue that way. And then in addition, as I've talked about previously, we have the back end where we're doing all this ML research, and it's really ongoing development. And so we're supporting this research platform so that we can keep advancing that. I think as probably everybody on this call knows, seasonal forecasts and hydrology is not a solved problem. So it's not like we're packaging something that's completely figured out and we're just going to make it easily accessible. We know that the science is going to move forward on that, and we want to make sure that we're moving forward with it. So this is our general plan. This slide was from our plan that we made in June for our NSF reverse site visit. So by September, which is where we are now, we have the version of the app that you guys just saw is actually an updated version from what we had in June. And we're ready to start launching more pilot studies and usability testing so that we can really fine tune the app. At the date that we're really targeting is by the end of the year to have actually a publicly accessible version. So right now, you guys can't just like go and play with the app. It has limited access, but to have actually a public release, and then we can start piloting, working on some custom applications. And by the spring, have our first options that we can be generating revenue from. We've talked a lot about what happened over the summer already. So what we're doing this fall, which is what's really relevant also to where I'm going to get to next, is that we have the app. There's a lot of things. We have long and short-term visions for it. So we have things like what you were talking about, Becky, that are things that we want to add in the future, but we've kind of left off the MVP for now. But then we also have a lot of questions about like, how can we make this more intuitive? What are the things that are low hanging fruit that we can make so that in December, if we had a public release where people are using the app that aren't also, on a Zoom call with us walking through it, they would be able to open it up and know what it is and get what they need. So that's what we're really focusing on for the fall, and also on making the app more stable, adding our QA/QC protocols. Then in the spring, we'll continue doing user studies, and then we're going to work on building the backend for custom user applications and developing user-specific workflows, adding additional tools, and of course, just expanding the capabilities of the national platform. And then summer, we'll be improving the user experience, expanding our capabilities, and continuing to optimize performance. And then as we go into phase 3, hopefully at that point, we do have continued funding to continue working on it and expanding it going forward from there. So what we're looking for from you guys now is, of course, we're happy for any questions and discussion you want to have. But we're also looking for beta testers that would be willing to work with our UE team to walk through the app and provide really specific feedback on, things that are intuitive or not intuitive. So we have a Google form where you can provide any just general feedback from watching Reed's demo today. And then there's also a place in there where you can suggest beta testers. If any of you are willing to be a beta tester, we'd also love to have you be a beta tester. So feel free to put down your own name if you have time. It won't be a huge time commitment. I don't know if we've narrowed it down, but we're talking about like a couple of hours, not like days of time from the beta testers. Do you want to add to that, Reed?
Yeah, I will. Thanks, Laura. So the link is in the chat. That's also the link on the slides, and that's also the QR code. And the beta testing will be 2 pieces. So as I mentioned, we're opening it up to beta testers now. We're sort of opening it up for the first kind of public release in December. And the beta testers will be there will be 2 activities involved in the beta testers. There will be the UEX team, which will be Charlie and Susan, which will sort of walk through like pain points, confusion, not necessarily with how things work, or I need more information on machine learning or hydrology, but like, oh, I clicked here and I thought I was clicking there, or like, I saw this, but I think that wasn't intuitive to me, or, they'll really work on the usability and flow from a beta testing standpoint. And then Elisa and Jill, the education outreach team, will also conduct some interviews and interaction. It'll be different because it'll be more about helping them better craft the explainers, the context-sensitive help, and other pieces that are more about questions about hydrology and machine learning, questions about, how best provide that kind of component of help. And as Laura said, it won't be, it'll be relatively soon. We're going to have this kind of before mid-October is the goal. So in the next few weeks, and it won't be an extensive beta test program. So it won't be a giant time commitment for the testers. And then we may not use all the testers that are suggested. So depending on how many we get, we'll kind of curate and try to get a good cross section across the different use cases and EAB members.
Great, thanks, Reed. So that's the end of our slides. So if anybody has questions, comments, you can also provide feedback to us here now. Feel free to jump in. I can stop sharing. Everybody has the link, right? And Gary will send out the link after this meeting also.
That's a lot. You guys have been busy.
Yeah.
I mean, lots of questions, but just in terms of the research program you envision going forward, like I find there will be a tension between, being part of an open community of development and sharing your, products but yet trying to differentiate and provide things for fee for service. And there's other, I imagine as part of this process, you'd evaluate your competitors in that fee for service space, and many of them aren't open. And so how do you have feet in both camps? Like how open are you going to be on the research side? And then how are you going to compete on the fee for service side, if you are open, given that your competitors will have access to, I don't know, at least they'll see it. I don't know. There could be kind of,
Yeah. So this is something we've talked a lot about, and I'll just start reading, then you can jump in. But so the way that, so we've gotten this question before, and it is definitely, I don't want to just like, it's going to be an ongoing challenge for us. Like, it is going to be something that we're going to have to be conscious of as we go. Our current feeling is that if we're doing things like training the national ML models, that's something that is only possible on our framework through the back end because of all of the national simulations we have. And we can make those simulations available. We can make the ML architecture available, and we can publish that. But still, it won't really, we don't see it would be undercutting ourselves, because the real value of the platform is the ease of use and the ability to put all of those pieces together with the observations to run in real time and to grab your watershed and have something running operationally. So we see that it would be possible to do things like publish our ML architectures and publish our national training results and things like that in an open format. And still, really the thing that people are paying for is that functionality. Because as we know, like, we already publish all of our modeling results, Parflow's completely open source, and there's not a bunch of people jumping up who have, are repeating that, because there's a lot of work in the setup and the software infrastructure. So that's my short answer. I don't know, Reed, if you want to say more.
Yeah, no, I think that was a great answer, and it's a great question, David, and something we have heard many, many, many times before. So the Convergence Accelerator program is really to sort of, accelerate the research to operations, and to really spin off. Originally, the idea was to spin off kind of for-profit startups. We have tweaked that quite a bit, because we're really sort of pushing more towards the nonprofit platform. And we believe pretty strongly that a lot of the users who need this the most are public sector, and or municipalities, and those that don't necessarily, that have the need but don't necessarily have deep pockets to pay. And so we're exploring a lot of possibilities for how to support the platform, because just because it's nonprofit doesn't mean that it's free, to how to support the platform for those users, how to sort of have be an open thing, support users that do want to use it for profit, that are, have the ability to pay, and to kind of balance that. And so that's been a real challenge and tension, throughout. NSF has been super supportive of our approach to sort of change that up some. And we're not the only of our cohort of 6. I would say I think 4 of us are also, kind of going for nonprofits. So I think that's a model that is being embraced through the Convergence Accelerator. But I think it is a challenge, and we're pretty committed to open source data, and and a lot of this is publicly available anyways. So it's it's something that we're kind of working towards. I know, David, you have your hand up, but Tim, you had your hand up earlier, so I want to make sure you got a chance. Did your question get answered, or?
No, actually, yeah, I do have a question. It's related to your initial conditions. I just wondered if your initial conditions are only pulling from, observed, actual physically measured data, or can you build in predictive things into your initial condition? Like, for example, NOAA releases every month what the El Nino, La Nina prediction is for the next 3 months. Currently, we're in a La Nina cycle, and they predicted a really high percentage, like 80%, that the next 3 months over the fall, we're going to remain in a La Nina pattern. Is there any way you can build that into your initial condition?
So the initial condition is really about the actual current state of the system. So we wouldn't build in things that are looking forward into the initial condition. However, we can build that into our scenario generation. So like if we know La Nina years, we can do analysis to say like, okay, based on that, we're expecting this to happen with the weather. But with our current conditions, we're not building in anything forward looking. It really is, like you're saying, it's just a snapshot of where do we think the watershed sits today. But also getting back to like what Becky said in Reed's answer there, one of the capabilities that's come up a lot is what you're saying of like, okay, but what if my current condition was wetter, because I think it's going to get wetter, and then this happened. So the ability to toggle around your initial conditions so that they're not actually just tied to exactly what we're seeing today is something that we are thinking about. Does that answer your question?
Yeah, okay, thank you.
Dave Tarbutton.
So I guess, it's exciting and it's ambitious, and some of these things have been tried by others. At some level, the National Water Center is trying to do a lot of what you're doing, but in a federal government space. What's going to make you succeed where other people have not necessarily been successful with similar kind of efforts? I really hope that it does.
I don't know. Sheer willpower. No, I think that's a really good question. And that's something, one of the reasons actually why we decided to focus on seasonal forecast was we felt like that was a space that was better suited towards the kind of research and forward-looking things that we're doing. We specifically didn't jump into like short-term flood forecasting or anything on the timescales of weather, because that's such a crowded space. And I think, David Lesmus brought this up in one of the previous meetings of it's a question of, collaboration, not competing. So, our intention is not to reproduce what the USGS is doing with observations. We're pulling them together so that we can use them easily in our framework. But if there's advances happening at USGS, we want to just collaborate and work on those. So I see us as being more collaborative than trying to succeed where others would, in competition with others, but it is still a really hard challenge. Seasonal forecasting is a big challenge. And I think one of the things is that in addition to doing the seasonal forecasting, we have a lot of other data products that are useful. So we can be moving the seasonal forecasting forward, but also be moving forward like the current conditions and our scenarios and all of these things at the same time. But I don't know, that's a hard question. Maybe Reed has a better answer for how we'll
No, this is something just to sort of, I'm not even augmenting what Laura said, but just kind of restating what Laura said. So this is something that, that we have thought very carefully with and/or struggled with since the very beginning. And we have intentionally not jumped into spaces where we thought that you know, other established groups. Well, I don't know about established groups, but other groups that were already, you know, working very hard. So Google has a, you know, massive flood forecasting effort. And what the National Water Center is doing is, you know, is a lot of overlap with Google, with other capabilities. What the, you know, what the river forecasting centers are doing, you know, a lot of this falls into that kind of weather timescale, which is why we jumped, you know, sort of the 3-month or scenario. And the 3-month was even really a push down from our original idea, which was way more scenario driven, way more, let's run a bunch of what ifs. But I still think it's a great space. I don't think it's a space that is as crowded as the 2-week space. And then, you know, we're not doing just stream flow at a point. We're doing, you know, kind of all of the water, and we're doing it in this, you know, kind of more probabilistic fuzzy approach, which I think is also distinguishes us from other efforts as well. And we could do groundwater, we could do soil moisture, which is also, you know, not necessarily an implicit target of the National Water Center. But, you know, there's a lot of people out there, and there's a lot of ideas, and we're not the first ones who've tried some of these things. I do think that we have some advantages in our experience in physically based modeling and our and the ability to leverage machine learning in a very different way. But, you know, that's why there's 2 tracks. That's why, you know, we don't know what the right you know, the right mix for a nonprofit or for-profit, or what that configuration is. And so we don't want to rule out, you know, we don't want to throw away all of the research that's been done, and we want to make sure that gets maintained throughout the process.
And Dave, I would just say, first, I really appreciate, you know, that sentiment of collaboration and community and doing it together. We've all been working on these problems for a long time. And I think there's also an element to that is the time is right. Like, technology has changed a lot. And I think you guys are kind of catching it at the right time to, like, you know, make the next step. And I think USGS could very much be partners. We're trying to do very similar things. And I think there's a lot of opportunity for partnership and collaboration across this space. And how it all plays out is just very uncertain. Who knows, you know, about companies and all these kinds of things. But I think in terms of place of community, we're getting to be at a good place. We're actually providing some value to people like Bureau of Rec that are really out there managing resources for the nation in desperate times. So, yeah, thanks.
Yeah, no, that is super well said, David. And as far as I know, neither Laura and I are planning to quit our day jobs and, you know, spin off this company. We sort of want to make sure that it's a community-based thing. I think that's also part of our real push to keep everything open, to keep everything open source, to be able to, you know, once you start closing things off, you start closing doors to more community access. And there's a tension between, you know, the competition and the collaboration. And I think that's something that we've always sort of, at least in my career, I've always chose to be open, to be more collaborative than competitive. But very well said, David.
And I know we're over our time, but I think another nice move is, you know, near-term prediction is so dominated by the atmospheric forcings to getting the weather predictions right. And the hydrological prediction is just kind of like a secondary thing in that. And so I think as a hydrological community, moving more towards a space where hydrology is front and center to evaluating longer term, you know, scenarios and, like models is, how do you say it, is well, heuristic tools for, you know, simulation-based inference, I think is a good place for the hydrology community to be in.
Yeah, and that's where we see really the advantage of having groundwater and soil moisture involved too, in terms of current conditions, especially. And I'll just add another thing that I think makes that we've been trying with our platform that's a little different than a lot of the like forecasting centers that are issuing, here's the forecast, is we really want something that is people can do scenarios, because we heard a lot in our early interviews with people, well, like, that one forecast isn't enough for me. I want to be able to turn knobs and say, what if this happened? What if that happened, in order to make better decisions? And that's why people end up paying so much money to build their own models. So the goal is we've really limited the degrees of freedom on our MVP app, but that we do have a platform that allows people to come and say, okay, what if it was dry and then we got a lot of rain? What if it was wet and then we got a lot of rain, or whatever? So, but I know that we're over time, so I want to be respectful of people's time if you need to go. Okay, so I mean, thanks for coming, you guys, and